So this is a differentiation assessment from the spring 2025 semester for Calculus 1 at Oklahoma State University. So the first page is just asks you to compute derivatives. So we'll just go through and compute these derivatives. So the power rule is here, so it's going to be 5 times 11x to the 11 minus 1 minus 6, and then the derivative of log base 3 of x. So we're going to use the following derivative rule, that the derivative with respect to x of log base a of x is 1 over x times the natural log of a. So that's the rule we're going to apply here. So it's going to be 1 over x times the natural log of 3. And then plus the derivative of e to the x is e to the x, plus the derivative of pi squared is 0 because pi squared is a constant. For the next one, I'm going to apply chain rule. The derivative of cosine I know is negative sine of, I'm going to leave the inside part alone, and then I'm going to multiply by the derivative of the inside, which is going to be 4 times 5t to the 4th plus 2 times the derivative of t, which is 1. So for the next one, I'm going to be taking the derivative of 5 to the x over x to the 7th. If you remember the derivative rule of a to the x is equal to a to the x times the natural log of a. So that's the derivative, one of the derivative rules we'll be using. We'll also be using quotient rule. So the derivative quotient rule is going to be low d high minus high d low over low squared. So the bottom is x to the 7th squared, and on the top I'll have x to the 7th times the derivative of 5 to the x, which is 5 to the x natural log 5, minus 5 to the x times the derivative of the bottom, which is 7x to the 6th over x to the 7th squared. So the next one, I'm going to be using the product rule. So when I take the derivative of this product, I need to apply product rule. So the structure of product rule looks like this. So I'll do the derivative of the first e to the 2x is 2e to the 2x. Leave the sign alone. Then I do the leave the e to the 2x alone. And then the derivative of sine is cosine. Okay, for the next one, again, is a chain rule. The derivative of natural log is 1 over, I'm going to leave the inside alone, tangent of t, times the derivative of tangent t is secant squared of t. So that's that one. Okay, for the next one, I'm asked to verify that the point 0 pi lies on the graph of the curve defined by the function. So I can say that the 0 is an x value and the pi is a y value. So if I do 3 times 0 times pi minus 2 times 0 squared equals sine of pi minus 0. I want to check that this equality holds. I can see on the left-hand side is just 0. On the right-hand side, sine of pi is 0, so 0 minus 0 is 0, so it does check out. For the next one, compute the derivative dy dx by taking the derivative implicitly and solving for dy dx. So to take the derivative here, I need to apply product rule, and I'll also need some chain rule here as I go along. So the derivative of 3xy is going to be 3 times, I'll leave the y alone, plus I'll leave the 3x alone, and then take the derivative of y, so dy dx. Minus the derivative of 2x squared is going to be 4x, and then the derivative of sine y with respect to x is going to be cosine, leave the inside alone, and then multiply by the derivative of the inside, which is dy dx, minus the derivative of x is 1, And then now I want to solve for dy dx. So this term here and this term here both have a dy dx in them. So I'll get those two terms on the same side and move everything else over. So I'll have 3x dy dx minus cosine y dy dx equals -1 minus 3y plus 4x. So I moved the terms that did not have a dy dx in them over to one side. Then I get dy dx. I can factor it out of the stuff on the left-hand side. 3x minus cosine y equals -1 minus 3y plus 4x. And then I can finish up by dividing over the stuff that's multiplied by dy dx. So I get dy dx equals -1 minus 3y plus 4x over 3x minus cosine y. So that is my derivative. Then it says compute the slope of the tangent line to the graph at 0 pi. So I want to compute dy dx evaluated at the point 0 pi. So I can get, I'm going to plug in 0 for x and pi for y. So I'll have -1 minus 3 pi plus 4 times 0 over 3 times 0 minus cosine of pi. And what I get is -1 minus 3 pi divided by 0 minus cosine of pi is 1. Cosine of pi is -1. So I'm going to end up getting 1 plus 3 pi for my slope. And then it says write the equation of the tangent line to the graph at that point. Remember, this is my x and y value, and I know that this is my slope m. So y minus y1 equals m times x minus x1. So I can just plug in my x1, y1, and my slope. So y minus pi equals my slope, which is 1 plus 3 pi, times x minus 0. And there's my equation of my tangent line. Okay, for the next one, I'm asked to compute derivatives. I'm going to need to use the values in this table to work this out. So if I have h of x is equal to x squared f of x, to find h prime, I need to use product rule. So h prime of x is going to be 2x, sorry, let me just slow down just a second. So the derivative of a product is going to have this structure. We'll do the derivative of the first, which is 2x, times the second function, which is just f of x, plus the first function, which is x squared, times the derivative of the second, so f prime. And if I want to compute h prime of 2, what that means is I want to do 2 times 2 and then times f of 2 plus 2 squared times f prime of 2. And I'll use my table to find those values. So f of 2 is -1, and 2 squared is 4 times f prime of 2 is +1. So if I add -4 to 4, I get 0. For the next one, I'm asked to compute m prime of 1. So that's going to be cosine. Okay, so m is going to be I'm going to need to do chain rule twice. Cosine of f of g of x times f prime of g of x times g prime of x. And I want to evaluate this at 1. So that's going to be cosine of f of g of 1 times f prime of g of 1 times g prime of 1. So let's start sorting these out. So g of 1 is here and here. I can see that g of 1 is -1. So I can plug in -1 in those two places. And then g prime of 1, I can find here in my table. G prime of 1 is -1. Okay. And then now I can look at f of -1 and f prime of -1. And so I get cosine of f of minus 1 is 2, and f prime of minus 1 is minus 1. So what I get is cosine of 2. And then it says compute k prime of 0. So I can see that k is this quotient. So k prime of x is going to be, well, it's just going to be the quotient rule. So f prime, f of x, low d high, excuse me. So it's going to be f of x, low d high, g prime of x, minus high d low, g of x, f prime of x, over low squared, so f of x squared. And then I want to plug in zero. So k prime of 0 is going to equal, well, I'm going to compute all of these values. So f of 0 is 3. G prime of 0 is 1. G of 0 is 0. G of 0 is 3. F prime of 0 is 1. And over f of 0 squared. F of 0 is 3, so 3 squared is 9. So what I'll get is 0 over 9, which is 0. All right, so the last one, the instructors were actually able to pick one of 3 options for this one. So this is the template, so I have all 3 options on here. So we'll just do all 3 optimization problems. Let's start with option 1. It says a hot air balloon rises from a launch site on the ground 4 kilometers away from an observer. The hot air balloon is rising at a constant rate of 5 kilometers per hour. How fast is the angle of elevation increasing when the hot air balloon is 3 kilometers off the ground? So the first thing I want to do is sketch a picture of the situation. So this is what is happening. So I have an observer, and I have a launch site, and I have a hot air balloon. So here is my triangle of what's going on. The observer is, we know, 4 kilometers away from the launch site, so we can label that with a 4. The observer is not moving away from the launch site, so that is actually a constant value, so I can leave that there. What I don't know is the height of the hot air balloon, or this distance between, actually, the question is asking us about the angle. So I'm going to label that angle theta. How fast is the angle of elevation increasing? Yeah. Okay, so that is my situation there. I'm given values of dH dt is 5 kilometers per hour, and I'm asked to find d theta dt. So if that's the case, then I want to find a relationship between h and theta. That is my goal. So what is that relationship? Well, I can look at the picture and I can see that that is a tangent. So tangent of theta is equal to h over 4. Next step, it says take the derivative of the equation implicitly with respect to time to show how the rates are related. So the derivative of tangent is secant squared theta times the derivative of the inside is d theta dt equals that h over 4, I can just think of that as 1/4 h. So it's going to be 1/4 dH dt. Okay. And so I know what dH dt is. I'm trying to find d theta dt. For the secant squared theta, I am going to need to draw another picture that is a snapshot at a particular instance in time. So when the hot air balloon is 3 kilometers off the ground, that will be this snapshot. So I can label the height as 3. I know this is 4. And I could use that, an inverse tangent, to find theta, or I could just go ahead and solve the other side of the triangle. So this is going to be square root of 3 squared plus 4 squared, which ends up being 5. And so I know that secant of theta is going to be the reciprocal of cosine. So it should be 5 over the adjacent side, which is 4. So I'm going to plug in my known values to solve for the missing rate. So I'll have 5/4 squared d theta dt equals 1/4, and then dh dt I know is 5. So I can multiply that over, and I'll get d theta dt is equal to 5/4 times 4/5 squared, which is equal to 4/5. And then the units are radians per hour. So that is option 1. So let's do option 2, maybe in another color. It says a 5'5" woman is walking away from a 20-foot light post at a constant rate of 7 feet per second. At what rate is the length of her shadow changing? So here we have this woman and a light post. So here's the light post. It is, I know, 20 feet tall, and that height is not changing. I also know that the woman's height is 5.5 feet. And that height is also not changing. So what I want to know is at what rate is the length of her shadow changing, so I'll call that L. And then I'll call this distance X between the woman and the lamppost. So I know that dx dt is equal to 7 feet per second. And I'm wanting to find dl dt, right? So the next thing says set up an equation that shows a mathematical relationship between the variables. So I want to find a relationship between L and X. So if I look at this, I should see similar triangles. So I know that L over 5.5 should be equal to X plus L over 20. And if I multiply both sides by the denominators, I get 20L equals 5.5x plus 5.5L. Then I want to take the derivative implicitly with respect to time to show how the rates are related. So that would be 20 dl dt equals 5.5 dx dt plus 5.5 dl dt. And so I can plug in the known values, which I know dx dt, and I can solve for dl dt. So I'll get 20 dl dt equals 5.5 times dx dt, which is 7, plus 5.5 dl dt. I can subtract that over, and I'll get 20 minus 5.5 is 14.5 dl dt equals whatever 5.5 times 7 is. And then I can divide it over, and I'll get dl dt equals 5.5 times 7 divided by 14.5. And you can get a approximation for that from your calculator if you want to. The units of that, L is measured in feet. So this will be in feet per second. All right, let's do one more. So this is the third related rate problem that could have appeared. We'll do it in green. It says a police car is traveling south at a speed of 90 miles per hour towards an intersection. So a police car is going this way. And is chasing a speeding car that has turned left at the intersection. So the car is going this way. Okay. and is now heading east at a speed of 85 miles per hour. So this is the cop car, and this is the speeding car, and this is the intersection. And so the distance between the cop car and the intersection is decreasing. So I can label that Y. And this distance between the speeding car and the intersection is increasing. I'll call that X. The question is, how fast is the distance between the cars changing when the police car is 1 mile? So we're looking for this distance between, so we'll call that Z. Okay, so I have here labeled all the quantities that are changing. So the cop car is moving towards the intersection, the speeding car is moving away from the intersection, and so on. So the police car is traveling, so I know that dy dt is going to be equal to, that's the speed of the police car, so it's 90 miles per hour. But if you look at this, the police officer is going closer to the intersection, so y is actually decreasing. So this should be a negative rates of change, negative 90 miles per hour. And dx dt, well, that distance between the intersection and the car is increasing, so it should be a positive rate of change. So they're going 85 miles per hour. And then we're looking for how fast the distance between the cars is changing. So I want to find dz dt at a particular moment. Then it says set up an equation that shows the mathematical relationship between the variables. So I'm just going to use Pythagorean theorem because this is a right triangle. X squared plus y squared equals z squared. Then take the derivative of the equation implicitly with respect to time to show how the rates are related. So I'll get 2x dx dt plus 2y dy dt equals 2z dz dt. Okay, and so I have values for dx dt and dy dt, but I don't have values for x, y, and z. What I need is a second picture, and this picture is going to be a snapshot at a particular time, and that is at the time when the police car is 1 mile from the intersection and the speeding car is 0.5 miles from the intersection. So this is our setup here. So from that I can find the z is going to be the square root of 1 squared plus 1/2 squared, which gives us approximately 1.118. And so I can plug in all those values. So 2 times the x is the 0.5 times dx dt, which is 85, plus 2 times the y, which is 1, times dy dt, which is negative 90, equals 2 times the z, which is 1.118, times dz dt. And then I can divide that over and solve for dz dt. So dz dt equals, 2 times 0.5 times 85 plus 2 times negative 90 over 2 times 1.118. And if I enter all that into my calculator, I get negative 42.4. So what that means is that the distance between the cars, that's the z, is changing at a rate of negative 42.4 miles per hour. So that means that it's the distance between the cars is decreasing because it's a negative value. Okay, that's all for that assessment.